This is Curvy Arrow Diagram Advanced. If you're watching this video, you should have already seen the basic video. I'm showing you the practice test right now, which is ionic compound curvy arrow practice test. You can get this in class, and I have the key for you to fill out the vocabulary. In the basic video, we went over how to do the diagrams when I give you the formula. Now we're going to go over how to do the diagrams when I'm asking you to predict the formula, which is on the back of the first page. So here you'll see that I just give you the two elements involved, and you're going to have to figure out the charges of the ions they will form and the ratio they combine in. So the first combination we have is barium and chlorine. So once again, you're just going to look up those valence electrons. Barium is right here in column 2, and like I said before, it's always going to be the first, second column, or over here with aluminum for your metals. So because barium's in column 2, it will have 2 valence electrons. I'm going to put them on like this. We don't pair until after 4, so 1, 2. All right, then we have got chlorine, and once again, chlorine's over here in column 7, and it's going to have 7 valence electrons. Now, we only have one single on chlorine, so I can just go right ahead and put in those pairs, right? 3 pairs and a single. All right, now I'm going to start transferring those electrons, and you can see right away there isn't going to be enough room for all of them here on chlorine. So I'm going to go ahead and transfer that 1 electron over here, all right, and exit out. So I've transferred that one, but I don't have any room to put another electron. So I'm going to add another ion to the side where I need more of something. I need more nonmetal because I need more places to put electrons. So I'm going to add another chloride ion, and it's going to bring with it its 7 valence electrons, just like that. And then I have a place to put that second electron from barium right here. Okay, and I X that one out too. So if you'll remember, my goal was to get to 0 over here, and for any elements or ions I have over here to have 8. So I've accomplished that goal. I'm done drawing electrons moving. I just need to put in charges on each ion. So barium lost 2 electrons. For each electron you lose, you become 1 plus more positive. So this is going to be a 2 plus ion, right? Because it lost 2 electrons. And each chloride gained 1 electron, so each one will be 1 minus, like that. Now net charge for my compound is 0, and I can predict my formula. Formulas tell us how many. I have 1 barium for every 2 chlorides, so I can write it like this. I'm going to write Ba without a subscript, and then my chloride symbol is Cl, and I'm going to put a subscript of 2. So that's BaCl2. Now you'll notice I don't include charge in the formula. No charge in the formula. Just how many with the subscripts. All right, let's do another example. Okay, so for our next example, let's see, magnesium, nitrogen. That's kind of a hard one. Let's do another easy one. So we'll just go ahead and do sodium and phosphide right here. Okay, so that was Na is the symbol for sodium. I'm going to draw that right here. And P is the symbol for phosphorus. Okay, it's going to make a phosphide ion. I'm not going to show you where I'm looking up the electrons anymore. We've been over that quite a bit. So sodium's going to have 1 electron because it's in the first column. Phosphorus has 5. We go 1, 2, 3, 4, 5. And then I start moving over electrons. Well, obviously, I'm going to run out of electrons real fast here. Okay, there's 1 electron moving from the first sodium, but I'm clearly going to have to add more sodium. I add to the side where I need more of something. I need more electrons to give phosphorus an octet. So I'm going to add another sodium, And I'm just going to take a leap here and add a third sodium because that's the only way I'm going to get all the electrons I need. So I put a second dot here and transfer that electron, and another dot here and transfer that electron. These guys have moved out of the way, and I'm done. I've got 0 electrons in each of my sodiums and 8 electrons on my phosphide. Now I put in my charges. Each of these will have a charge of 1 plus because each one lost 1 electron, and my phosphide will have a charge of 3 minus. I figure out my formula by counting the number of ions on each side. I don't care about charges. 1, 2, 3. So I'm going to say Na with a subscript of 3 and P. No subscript means 1, right? It wouldn't be in the formula if I had 0. Na3P. That's my formula for sodium phosphide. One more example. We'll do an advanced example now. And so this one is going to be another 3:2 ratio here, magnesium and nitrogen. My charges right now are going to turn out to be 3:2, but my formula will also be 2:3 then. All right. So we've got magnesium, Mg, and magnesium has 2 valence electrons, and nitrogen, and it's going to have 5, like that. Okay, now I'm going to transfer over 1 of those electrons from, no, 2 electrons from magnesium to nitride. So there's 1 of them going over, right? And then here's my second one going over here, all right? But now I've gotten rid of both of those electrons on magnesium, and I need more electrons. So I'm going to add to the side where I need more of something. If I need more electrons, I'm going to add to my metal side. So here's another magnesium, and now I'm going to move that electron over here. Okay, so that's done. Now, I don't just have to add to one side. I can add to the other side too. I'm out of balance. I've got to keep going until I've got it balanced. So I'm going to add another nitride. It's going to bring along with it the valence electrons that nitrides bring. That's 5. And I'm going to move this second electron on this magnesium to this slot here. Now, this magnesium's good, but I'm out of balance again. What do I need more of?
Jeremy Kennedy, can you come to the front office or call 6658, please? Jeremy Kennedy, front office or 6658.
Oops, sorry about that. All right, I'm going to add to the side that I need more of something. I need more on my magnesium side because I need more electrons. So I'm adding a second magnesium, or a third, I'm sorry. And now everything's going to balance out, right? So I'm going to move this guy here, and I'm going to move this guy all the way around here. X these guys out, and now I've gotten rid of all my electrons on my metal side, and both of my nonmetals have 8. That's an octet. So I have my formula for this compound. It's going to be Mg3, 3 magnesiums for every 2 nitrides. And I've kind of run out of room here, so I'm going to turn my board like this to write out my formula, and that is going to be Mg sub 3 with an N2, like that. Okay? No charges. All right, I hope you found this video helpful, and I look forward to seeing you in class. Good luck.